All right, welcome everyone again. Thanks for joining us for today's workshop on using Pulumi for infrastructure as code. Thank you all for being here. So for the workshop today, we're going to be going through sort of a quick introduction to kind of infrastructure as code concepts and to Pulumi. Then we're going to spend a lot of the time in a hands-on kind of lab. I'll walk through it on screen for folks, but we'll also have plenty of time for folks to dive in and start using Pulumi yourself, ask questions, and just answer anything that you want to know about getting started with Pulumi. So there's a few places where you'll be able to ask questions throughout the webinar today. So through the webinar tool itself, if you want to raise your hand in your attendee panel, or drop a question in the questions panel, either one of those, we will jump on them and try and answer your question and see if there's something we can talk about with the group as well. So we'll try to stop frequently to address those questions as well. And then also we do have a Pulumi community Slack, which is a place where we have a lot of great discussions around Pulumi and around infrastructure as code. During this workshop, we'll be on there in the Hash Workshops channel. And so feel free to join us in that channel to ask higher bandwidth questions as well, and have other folks from the community jump in on those as well. All right, well, let's get started. As I mentioned today, we're going to be talking about getting started with infrastructure as code. So we're going to be starting with some of the sort of foundational concepts of both Pulumi and infrastructure as code. And we've actually split up the workshop. We were originally going to do this as an in-person workshop in the Bay Area. And because we're now obviously doing it online, we've split it up into two parts just to make sure that we don't try and keep you guys all in a webinar for 3 hours straight. And so we're going to today be doing about an hour and a half kind of an introduction to some core infrastructure as code concepts and core Pulumi concepts. And then next week, we've scheduled another follow-up webinar, which will go into some more advanced infrastructure as code concepts and some sort of more advanced modern cloud native architectures and how we can work with those using Pulumi. So if you were interested in attending the second half as well, definitely feel free to sign up for that session as well, which I think is next Thursday, a bit earlier in the day than this one is. So hopefully you'll be able to join us for both of these. In terms of for folks who want to follow along, and definitely encourage anyone who can to kind of follow along with the workshop today. The three key things you're going to need. One, we're going to be focusing on AWS today. Some of the workshop content we have is available also for Azure, but I'll be focusing on sort of the AWS part of it in the demos I do, and be talking through some of it from that lens. So definitely, if you have an AWS account, that's going to be the easiest way to kind of follow along with that. If you don't, drop us a question, and we'll see what we can do to help you get set up. We do have a Pulumi account we can use to give some of you guys access to AWS if you need to, just for the webinar. So definitely drop us a note if that's something you're interested in. And then the second one is obviously Pulumi. We're going to be using Pulumi as our tool to deploy our infrastructure as code. And so you can click on this link here, or just type in Pulumi install in Google, and go ahead and download Pulumi if you have not yet. Once we get into the workshop itself, we'll be using that extensively. And then finally, Pulumi works with a variety of different programming languages that you can use to deploy your infrastructure. So you can work with JavaScript, you can work with Python, you can work with C#, you can work with Go. I'll be demoing today in Python. And so for folks who kind of want to follow along with me, you can use Python, but really whatever you're most familiar with here, feel free to make sure you just have that language runtime installed as well. And we'll use that to deploy our infrastructure. So while we're going through some of the other content, if you haven't done any of these things, definitely encourage you to go ahead and do that now. So also to make this a little more interactive and to get some of the sort of feedback from the folks who are attending, would love to have a few of these kind of polls throughout the workshop to sort of hear from you. And the first one I have is sort of the question, who plans on following along with the hands-on lab? If you do plan on following along, would love to do that. If you don't plan on following along and you just want to watch kind of demos and ask some questions, that's fine too. Let us know. And so you should be able to respond at polev.com/LukeHoban275 that it shows up at the top. And I'll give folks just a minute to reply here before we get going with the actual content. realize now it's not telling me how many people voted, so I can see the numbers changing, but I'm not sure what the total is. Okay. Okay, so we've got a good mix. Quite a few folks are gonna follow along, but definitely some folks planning to just kind of watch. And so both of those are fine, but great to hear. And if you do want to follow along and need any help with any of the prerequisites, just drop us a note as well. Great. All right, let's keep going. All right, so first let me just sort of do a quick introduction to kind of infrastructure as code concepts that are going to be kind of important to think about, what Pulumi is and why it might be interesting for you or your team. So really when we're talking about infrastructure here, we're thinking about sort of all the different things that you need to work with in terms of the cloud infrastructure you use to deploy your software into a cloud environment. And so that can mean the things you're probably most familiar with, like, hey, it's your VMs, it's your containers, it's your serverless functions that you kind of work with most directly. But it also means all the other pieces of infrastructure you need to set up to make that be successful. So that's sort of the foundational pieces, whether it's security things like IAM and KMS, or networking, or some of the monitoring and logging capabilities you want to configure. All of these different pieces that you need underneath your infrastructure to set it up are the infrastructure as code that we're going to be able to work with and manipulate using Pulumi. At the same time, we're also going to be talking about sort of some of the data stores you might be working with. So the things that your applications need to store and manage their data. The life cycle of those, we also want to manage in an intentional way as part of our cloud infrastructure. And finally, just the applications themselves, and how do we get the applications that we're building into the infrastructure? How do we get the images for our VMs in? How do we get the container images in? And how do we package up and ship code into serverless functions? And so all of this is sort of what we think about with infrastructure as code, is sort of finding a way to describe using code what all the different pieces of our infrastructure need to do. And one of the things we've seen is a big sort of shift over the last, say 5 years or so, has been sort of the transition we're seeing within how folks are building kind of cloud infrastructure, how they're using cloud infrastructure within their organizations. And I'd say in the first wave, it was these fairly simple, fairly static kind of infrastructures where it was really one VM, you SSH'd in, you ran some commands on the VM to like launch your app or to set up your MySQL instance. And it was very simple from an infrastructure perspective. It was just, how do I get my VM and how do I SSH into it? There wasn't a whole lot of other stuff that I was working with. And then in sort of the early cloud wave, I'd say we kind of got the slightly more complex. We had more VMs. We weren't necessarily relying on just SSHing into managing them. We were actually using provisioning tools within the guests to reliably stamp out our application behaviors. And we were using more abstractions. We were using Docker. We were using things like Datadog to do, to do log extraction, that kind of thing. And so we were kind of building up more of these pieces of our infrastructure. But as we get to sort of more modern cloud infrastructures, where we're using containers, we're using serverless, we're using more managed services as part of our applications, we're finding that there's actually lots more different pieces involved in how people are building that infrastructure. And so the infrastructure as code is becoming a more important part of the way that people build and deliver their applications, because infrastructure as code is what describes the glue between all the different edges on these diagrams. And this may look in some sense more complicated than the previous ones, but in some sense, the key benefit you're getting with these modern cloud infrastructures is that the dark gray here is really the code that you own. And that code has been reduced. So a lot of the operational burden that you might have had in sort of some of the pre-cloud and early cloud phases, that operational burden is now something you're able to hand off to AWS or Azure or Kubernetes or some other system. And now you're responsible for less of that code, but the thing you're responsible for more of is the glue between those different services that are being managed by your cloud provider. And so some of the complexity shifts into that space, and therefore infrastructure as code takes on an increasingly more important role in how we manage that with modern cloud. And so because we have all this infrastructure we need to manage, we have to think about kind of how are we going to manage that. And I'd say there's a few different approaches that have kind of been used and are still being used throughout the industry. Yeah, obviously, there's this sort of manual approach of just, I'm going to go into my console, I'm going to point and click, I'm going to create a VM, I'm going to create a Kubernetes cluster, I'm going to create a serverless function. And of course, we know that is easy to do, but not going to scale up well. as I want to make changes, as I want to replicate what I've done, as I want to reliably understand the state of my infrastructure. It's become very difficult to do that if I'm manually managing all of these things. And so folks then mature into sort of automation, where they're writing bash scripts and that kind of thing to kind of automate this process using the raw APIs from the cloud providers. And that gives me a little bit more repeatability, but still a very complicated set of scripts I've got to manage that are very customized to my environment and don't handle frequently a lot of the corner cases that are very important for reliable infrastructure. And that's really where we get to infrastructure as code, which is the ability to write down in a reliable way what infrastructure needs we have and what we want the desired state of our infrastructure to be. So that's what we're really going to focus on today with Pulumi. So there's a few sort of traditional approaches to infrastructure as code, and folks here are probably familiar with things like CloudFormation, JSON encoding or YAML encoding of the resource model of AWS. And so the way to tell AWS, here's a set of resources that I want to have given these properties and with these references between them. And of course, doing this in JSON is, or even in YAML is pretty, is pretty author unfriendly. There's not a whole lot of support around how you author these things. It's very slow, not a lot of help from a software engineering perspective. But it has the raw object model I want to be able to describe and manage the resources in my cloud. It's a very popular kind of tool to use for managing cloud infrastructure. With Pulumi, that we're going to be talking about today, we kind of take the same model of having a resource model for the cloud, but we expose it to programming languages. So to languages like Python, TypeScript, or C# or Go. In this example, we have some TypeScript code that constructs the same resources, EC2 security group, EC2 instance, and lets us work with those and define the properties of those resources within our code, but we're still building the cloud infrastructure. And now, of course, when we're real code, we can do a whole bunch of things that sort of you can't do when we're just in sort of something like a JSON or YAML DSL. And so it's very simple things like, hey, I can write a for loop here, so I can get every availability zone and create an instance per availability zone instead of just creating one instance. But that's just really the tip of the iceberg. There's so many other things that sort of once we bring kind of real programming languages and real software engineering capabilities in, so many additional things that we can think about doing. So loops and conditionals, we can create abstractions and we can reuse capabilities. So we can create reusable functions that build up sets of infrastructure. We can put those into classes that have well-defined interfaces on them. We can put those in packages and share them across our organization as reusable components of infrastructure that capture best practices and can be reused in different places across our team. And then finally, the key thing to note is that Pulumi, although it is real code and it does let you use sort of an imperative programming language, this is still a declarative model of infrastructure as code. So the program that I write in Pulumi, I run, and it actually describes that the end result of running that program is the desired state I want my infrastructure to be in. And then Pulumi takes care of moving my infrastructure from the state it's in into that state. And we'll see that through the demos. But it's a really important thing to understand that Pulumi gives you the best of both worlds here. It gives you that expressiveness of an imperative programming language with loops and conditionals and classes and all these things, along with the declarative model of desired state infrastructure as code. And so we're going to get to see kind of both those pieces. And then finally, of course, by using real programming languages, we get all the benefits we have in those language ecosystems. So the IDEs, the linters, the compilers, the test frameworks, all these different things that we can apply from these languages that we use in our application code. We can now bring those to bear on our infrastructure code as well. And then finally, of course, for many folks doing cloud infrastructure work, they're sitting at the boundary between sort of traditional kind of IT cloud teams and application development teams. And we want those to be closer together. We want those development teams to be able to iterate more quickly on their infrastructure. And so enabling our developers and infrastructure engineers to collaborate more closely, enable more empowerment of our developers to do infrastructure is a key thing we get from bringing it closer to the programming model that they expect from the languages they're used to using, working with. Okay, so with that quick overview, and we'll get much more in as we show some code in a second, but would love to hear, for folks who are here, what languages are you expecting to kind of work with today, or once you do decide to work with Pulumi? Okay, good. Lots of Python. I'll give just a couple of seconds for everyone to put in their votes. Great. Okay, so I think that's a good survey of it. So that's perfect. I'm going to be showing it off in Python today, but the workshops are available in TypeScript and Go as well. So folks should feel free to try following along in those languages as well. We'll go ahead and get started now. So in the first lab, this is going to be pretty simple. We're going to kind of go through the end-to-end experience of kind of working with Pulumi, but with just some very, very simple resources. So we're really going to focus on just an S3 bucket, a resource that everyone understands. It's very simple conceptually. And we're going to work through kind of what are the life cycles, what are the flows that you're going to kind of use with Pulumi generally, but constrained into a very simple set of resources. And so this will be a chance to learn Pulumi, learn the infrastructure as code concepts. And then in future labs, we'll kind of go and apply those into some of the more complex domains around different kind of compute formats. And I see there's a question here. So okay, before we dive in, let me answer one of these questions. Hamad asked, could you explain more of how the link between imperative code that generates declarative output that Pulumi executes works? What is the declarative output format for Pulumi processes? So there's not actually a declarative output format with Pulumi. So Pulumi will actually sort of run these two processes in parallel, the process of you describing what your desired state is and the process of resolving that desired state against your cloud. And I'll show this a little bit more once we get into kind of talking through some of the steps in this lab. So there's no serialized format in between, but the program is defining the desired state. So when you just say you want a resource with a certain set of properties, what that's saying is this is the desired state I want that to be in, and Pulumi will go and modify the resource that matches that to match the properties that you specified. There is a state file, of course, with Pulumi, so you can understand what state is the deployment in if you need to, and I can show that in a second as well. Great. Okay, so for folks following along, you can just search for the Pulumi Infrastructure as Code workshop. It's up on GitHub. I'll bring it up as well here. So this is the workshop content right here. And what I'm going to do is while folks kind of get started themselves on this, I'm going to go ahead and walk through a couple of parts of the AWS Python lab here, lab 1. And I'll just show those off while we're going. If folks do want to do it themselves, feel free to kind of mute for a little bit, try to make some progress, and I'll check in on folks in a second. But folks who do want to just watch, I'll just show off kind of how I'm going to work through some of this workshop as well. All right. So let me go ahead and get started. So I'm going to follow along with Lab 1. So what I'm first going to do is just create a new folder for this ISE workshop. And I'm going to change directory into it. Now, when I want to get started with Pulumi, the easiest thing to do is say Pulumi new. And this will let me pick a template that I want to work with. And so there's a whole bunch of different templates here. What I'm actually going to do is go to a very simple one here. Oops. So many on the screen when I have this font. I'm just going to start with the raw Python template, which is not connected to any cloud yet. This is just the raw artifacts I need to work with Python. And so I'm going to say, open this up in code. Okay. Okay, so I'm going to go ahead and start it. Here are the files that I got when I ran Pulumi new. So there's 4 files here. You'll see a couple of things. One, there's a requirements file. So this is just because this is a Python project. These are the libraries I'm going to use. And so you see that Pulumi itself is just a library that I can access. And all the different cloud providers, in a second we'll see, are libraries I can use as well. Pulumi YAML file is sort of the root of a Pulumi project. So this describes that I have that workshop IAC project that I'm working with. The runtime I'm going to use for this project is Python, and I can leave a little description of that as well. And then finally, I have my actual program. So this is my entry point that I'm going to use to run and describe the infrastructure I want to deploy using Pulumi. Before I get going, let me just go ahead and grab these commands that it gave me. So I'm going to start up a virtual environment. I'm going to activate that virtual environment. And I'm going to install the requirements I have. Okay. And now, just to make our IDE happy, I'm going to point at that new virtual environment that I have there so that I get all the IDE support that I just talked about. Okay, so now I'm going to go ahead and get started writing some actual code. So because we're going to work with AWS here, I'm going to just do pip install. Okay, so now I've installed AWS as well, and so now I can say import Pulumi AWS as AWS. Now, one of the fun things is that once I have AWS, the AWS package, I can sort of see all the different things that are available within this package. And so you can see that the entirety of sort of the AWS API surface area is available here. So if I wanted to work with EC2, I can do that here. If I wanted to work with ECS, I can do that here, create an ECS cluster or an ECS service. If I want to work with IAM, all the different resources that I might expect to see from identity and AWS are all available here as well. So the entire surface area of AWS is available within my IDE and within my programming model here. And Pulumi supports a lot of different cloud providers as well as AWS. So AWS, Azure, GCP, and then I think we have 50 or so providers for a whole bunch of other cloud and SaaS platforms as well that you can work with if you need to work with those as well as your primary cloud platform. Okay. So now we need to tell Pulumi kind of what region we want to work with in AWS. So I'm going to say Pulumi config set AWS region. US West 2, that's close to me, so it'll make everything a little bit faster. Feel free to use whatever region you want to work in. And then, of course, if you do need to work with a custom profile or certain configuration settings, you can do that by setting your AWS profile or setting other configuration settings, like if you set AWS profile, that can point at a different account that you might have access to. So there's some docs in the workshop there that you can follow, or you can go and look at some of the getting started guides if you do want to set up some custom configuration there. Okay. So the next step, I'm going to actually try and deploy something. So I'm going to say I'm going to have a bucket. I'm going to say aws.s3.bucket. I'll call it my bucket. As soon as I don't know why this wants to. Okay. So now that I've written that, what I can do is say Pulumi up. And Pulumi up is the key command that we'll use to actually deploy our infrastructure. And so Pulumi up will say whatever is in the code, we're going to run that program and we're going to deploy the infrastructure that program describes. And so in this case, you'll see Pulumi up, what it first does is shows me a preview. And so it says in the preview that it's going to create two things. One is this Pulumi stack, which is a virtual resource that just is a container over all the other resources in my stack. This isn't a real thing we're going to construct in AWS. It's just a thing that Pulumi is using to keep track of all these resources. And the second thing is, of course, that bucket that we specified. And so we can see the AWS S3 bucket. Then we can go to our details. We can see some of the details of what it's going to create. It's going to be private. It's going to be, here's the name it's going to create. And you notice that it actually added a suffix here beyond what I specified as the name. And so there's two names that are going to be useful to think about when we're working with Pulumi. The name we specified here is the logical name we're going to use to refer to this resource. So within our Pulumi program, it's going to be called my bucket. But of course, we may want to have two copies of our Pulumi program deployed inside the same AWS account, with the same AWS region. And so we want, by default, for us to be able to instantiate this multiple times and not have those potentially conflict with other resources. And so by default, Pulumi will actually add a suffix to make sure it's unique to every resource. Of course, if I wanted to specify the exact name, I could make sure I make up something that doesn't exist. And we'll see now if I run a preview that it's going to use that name instead. So this is now the logical name that Pulumi is going to use to refer to it, and this is the name that we're going to use in AWS for. Okay, but I'm not going to do that right now. I'll just stick with the the name that it gives me. And after I see the preview, I'm just going to go ahead and say yes to deploy this. Okay, so now we've actually deployed that out to AWS. So now to actually go and see that resource from our console, one of the things we might want to do is export out the name of this resource so that we can get it and work with it. And so what we're going to do is just add an export to this code. So we're going to say Pulumi.export, bucket name. Let's export the ID. Okay, so now we've got in our outputs, we have this bucket name there. And these outputs that we see here are actually available from the CLI by typing Pulumi stack output. So we can see all the different outputs that we've specified from our program. And so we can get a hold of those from out here. And so we can do something like AWS S3 LS, Pulumi stack output, bucket name. Of course, you should expect to see nothing here because there's not yet any files in our bucket. Now, the other thing I'll just quickly touch on, when we're storing the state, and for those who have gone through the workflow here, one of the things you may have noticed when you first installed Pulumi, it asked you to log in. And one of the reasons it asks you to log in is because we're storing the state of our deployments that we're doing here, so that we know what has been deployed to AWS. We're doing that in the Pulumi backend service. And so by default, we store that state in a service that we provide at pulumi.com. You can, if you want to, go and manage that yourself, either on your local disk or in S3. But we can go ahead, once we're doing this inside with the Pulumi console, we can actually go and look at what this looks like here in the Pulumi console. And so there's two updates I did. We can now see the history of those. And we can see the first update created 2 resources. The second one, all the resources were unchanged. We can also come in the resources tab here and see the resources that we have. So we have this AWS S3 bucket, and I can click on this, take me over into my S3 console. And here I go. Now I've got my S3 bucket here as well. Okay, so I've gone through some basic stuff. Let me pause at this point, just jump back into the slides and just check in on kind of how folks are doing. So would love to hear kind of how far folks are through and where folks need any help. And if you do have questions, now's a great time to raise your hand or drop a note in the questions tab. All right, so it looks like plenty of folks who have finished it all or are not following along. So I'll go quickly then through the rest of it. For folks who are following along and are kind of in the early parts of it, if you have any questions, need help, drop us a note so we can help you get going. Okay, great. So let me move on then to the next section. So now that we have a bucket, we want to put some stuff in the bucket. And so what I'll go ahead and do is create a folder called site here. And I'll create a file in that folder called index.html. I'll grab some code to put in my HTML file. Okay. Now I want to be able to use that file, so I'm going to just use my Python library. So in this case, I'm going to use the import OS library. And now I'm going to use that to construct a path to the site folder, and then look up that index.html file. And I'm going to go ahead and create a second resource using Pulumi. So I'm going to use aws.s3.bucket object. I'm going to call this bucket object index.html. I'm going to set a couple of properties on this. So the first one is I'm going to set the bucket that I want to put it into to be bucket.id. Second, I'm going to set the source that I want to install into that bucket to be pulumi.file asset. I'm going to pass that file path. So a couple of things I should just note as an aside here. So the first is that I am actually working with, I'm actually getting sort of all the kind of IntelliSense and that sort of thing. So when I type database.s3.bucket object, I kind of see what that is. If I command click on this thing, I actually go to definition into the Pulumi library. You can see all of the different properties. I can see their types using Python's MyPy typing. And I can see the doc comments and all that kind of thing for that. So I get all that sort of IDE support as well. Also, you see that I'm able to refer to other resources. So when I'm creating this bucket object, I'm referring to the bucket I created previously here. And that's going to actually implicitly create a dependency between those resources. And so this bucket object resource is going to know that it depends on bucket. And so it can't get created until after bucket's created. And when we want to destroy the bucket, we're going to have to destroy the bucket object first because we need to remove that from the bucket before we can get rid of the bucket. And so understanding those dependencies is a key thing that the Pulumi program is doing as you're deploying it. And finally, we have this file asset, which is a way of pointing at some content on your disk and actually making sure that we're doing the diffing to make sure that when that content changes, we're actually going to change what we upload into the bucket object. So let me go ahead and just deploy this. So I'm going to say Pulumi up again. And the thing we'll note is that in this case, we don't have to do anything new to our bucket. It's still there. It still matches the specification we gave for it here. The only thing that's new is this bucket object. And so we're going to go ahead and create that. And so the details, you can see the key of it is index.html and the source is the contents of the site/index.html file on my local disk. So I'm going to go ahead and say yes, and this will upload that file into S3. If I come over here and refresh, we should see our file is now there. And if we come over here and do an S3 ls, we'll see that the file is also S3. Okay, so now we've managed a couple of different resources. We've also used some sort of capabilities in the Python core libraries to work with this. Let's take it a step further and turn this bucket into something that can serve our HTML as a website. So for this, we're going to actually modify the configuration of our bucket. So now we'll have the same bucket, but we'll have its have some different properties on it. So we're going to say index document is index.html. So this is a configuration setting we can use, and we can again command click. We can look for the website property. Oops. We can see that it is a website object. We can go look at the details of kind of what that is and how it's configured. And it's an object that configures when I'm serving this as a website, what document should I use as the default index document to display. And so we're going to specify that index.html file that we specify. Next thing we need to do is make sure that we're uploading our files with the correct MIME types. And so this is another place where it's really handy to have a real programming language where you can use all the different libraries that are available there. In this case, we can use them to understand what the MIME types of all the different files we're looking at are going to be automatically without us having to hard code that in. And so now what I'm going to do is say MIME type underscore equals MIME types.guessType. And this is just a built-in Python library that guesses the type of the MIME type from a file's name. Okay, so now we have that. We'll actually add it into the specification of the object. So S3 bucket objects have the ability to set their content type, and so we'll set that to the MIME type that we just discovered. And because we want to serve these now out of our bucket, we're going to set this to public read. So we're going to make it so this particular object can be seen externally, so that it can be served as part of. And finally, now that we're serving this as a website, we also want one extra export, which is the bucket endpoint. And so we'll get the website endpoint there. Now, actually, we want to do something slightly different. Well, actually, I'll just go ahead and deploy this first, and we'll see what that looks like. Okay, so the preview tells me it's going to update my bucket. It's going to add the website property, and it's going to update my bucket object, and it's going to modify the ACL and the content. So if I go to the details, we'll actually see it's going to sort of do a slight coordination of a few different updates here. So it's going to add that resource and it's going to modify these. It also knows that there's a dependency between these, so it'll make sure to do them in the correct order. We'll see that it's changing the content type from binary archetype stream, which is the default, to text HTML. Let's go ahead and say yes. So we update the bucket first and then the bucket object, and now we see that our endpoint is also available. Now, the one thing about this endpoint is this is actually an HTTP address, but it's missing the HTTP at the front. And so what we want to do is we want to add HTTP to what we export here, so this is a bit easier to use. And so this is where sort of we start working with some of the more interesting Pulumi concepts. So this bucket website endpoint, like every other property that's an output of a resource, is going to be of type output in our programming language. And so in Python here, it's an output, and in TypeScript, it'll be an output of T. And so this is a value that is not actually just a string. It's a wrapper around a string. You can think of a bit of like a promise or a future or any of that kind of thing. But that represents the value that will be available once the resource has been provisioned. So until the resource is provisioned, we won't have a value. And then once it is, it'll be available with the string value that you specified. And so in our case, what we want to do is actually create a new output, which is based on that output, but concatenates a few different things together. And so in this case, it's going to concatenate HTTP : to the front of that website. And so as output.concat, you'll see takes vargs of inputs. And so inputs can be either strings or outputs, and stitches them all together once they're all available into a new output, which it will return and it will export as the bucket endpoint. It's just sort of a way of doing interpolation of values and sort of computing new values out of the ones you got. So we'll go ahead and do Pulumi up there. That'll just change our exported value. I'll say yes. Oh, I didn't save my code. Just to speed things up, I'll skip the preview. Okay, so now we modified our export from being just this to being this HTML address. So now I can command click that to open it up. And look at that, we got our hello Pulumi. Alrighty, so now we've actually served this file out of our bucket. I guess the other thing we can do just to show that off is we can do a Pulumi stack outputs website bucket. So we can also see that we can just curl it here. That'll make it a little bit easier to test this as we go on with other steps. Okay. All right, so for the next section of this, and again, if folks do have questions, feel free to throw up your hand or ask a question in the panel, and we'll jump on that. But if not, well, I'll just keep going. Okay, for the next step, we're going to look at a config. So Pulumi supports configuration so that we can take inputs into our Pulumi program here and set those outside of the program and configure it differently every time we deploy it. And so what I'm going to do here is say config equals pulumi.config. Then I'm going to pick a configuration setting I want to make available, which is config.require. I'll call it site dir. Okay. So what this is going to say is that I want my the people who deploy this stack to specify a site directory that they're going to deploy into. And now that I've specified that, I want to actually use it. So instead of me hard coding the word site here, let me just use my site dir. I think that's the only place I hard coded it. And then to just show off that this is really working, I'm going to move my site directory to www directory. So now if I try to Pulumi up, what we should see is that it will give us an error. And it gave us an error because we said that this was a required configuration parameter, but we didn't specify it. So we said it's missing the site dir parameter here. And so it tells us what we can do to set that. We can do Pulumi config set. In this case, we can just specify site dir because it's a setting for just this project, not for some other package work like AWS. And in our case, now we name that www, so I'm going to set that. And now I'm going to Pulumi up again. And this will deploy with that new configuration setting. Now, the Great thing about this is, of course, even though I've added this parameterization to my application, I haven't actually changed anything. So the desired state is still exactly the same. And so 3 unchanged, I say yes, and I'll go ahead and make no changes to my application. So now that we've specified this, we can actually go and add some more files. So in my www folder, I can say about.html, grab some content to put in there. And now that I've got that file there, what I want to do is, instead of me just hard coding in again, like I could come in here and add yet another bucket object, that points at, instead of index.html, it points at about.html. But we have real programming languages, so we can do this more easily. We can just say for file in os.lister. Now we just hit tab, and suddenly we're now creating as many bucket objects as we need to for every file that was in that folder. Actually, one slight thing we got to change is change index.html to file. Okay, so a very simple change to our program. Now I can Pulumi up, and this will actually come up with a different desired state. So because it runs that for loop, it runs it once and finds the index.html file, and so it doesn't need to change anything with that. But then it runs a second time and finds this about.html file. It says it needs to create that. So we'll go ahead and deploy that. Okay, so now we can go ahead and just take this and curl our about.html endpoint. So there we go. We see that we have that new content up there as well. So just a really simple thing, because we have for loops, we have access to, and we have access to all these libraries. Very simple to write, sort of reliable code that does this sort of thing. Of course, the even better thing we can do is we could sort of take this whole concept here, and we could wrap that up inside a reusable function or reusable component that knows how to do this. We could, instead of just listing this one directory, we could recursively list all the files inside that directory. We could sort of take all these different concepts we think of from kind of our programming languages and our software engineering. We could use those to sort of abstract away some of this complexity into a simple concept for syncing a bunch of files into an S3 bucket. All right, now there's one more concept that's sort of useful to kind of highlight here, which is the ability to manage multiple stacks. And so far I've been working with, if I do Pulumi stack ls, working with a single stack. And so this has been the dev stack, and this was created for me automatically when I ran Pulumi new. And so I've been able to just deploy all these resources into this one environment here. But I might want to create a whole nother copy of this same infrastructure, which is going to use the same program, same project to deploy. But it's going to be a separate deployment. So this might be, I've got my dev and my prod environments where I've got my personal dev stack that's independent of all the resources that are being managed by the rest of my team. And so if I want to create a new stack, I can say stack init, and I'll create prod stack. Now if I type Pulumi stack ls, you'll see I have both my dev stack and my prod stack. My dev stack has those 5 resources. My prod stack doesn't yet have any resources. So now what I might want to do is actually, configure this one a bit differently than the previous one. So instead of me using that www folder, why don't I create a different folder? So I'm going to create a www prod folder. I'm going to copy that index.html file over, and I'm going to say from production. So this copy is going to be a bit different. Now I can set some settings here. So I can say Pulumi config set AWS region US1, and Pulumi config set sector to www prod. So now this stack is a separate deployment of my same program, but with different configurations. So this time it's going to deploy into a European data center of AWS, and it's going to deploy a different set of files because it's going to point at a different folder on disk. So now I can say Pulumi up again. And this time we should see it trying to create all the resources from scratch because there's no resources yet deployed into this copy of the infrastructure. And so we'll see it's going to create my bucket, and only one bucket object this time because we only have one file in our www prod folder. Go ahead and say yes, and that will deploy these. This will take us a little bit longer because we're going to a European data center here, so my computer is a little bit further away from it, but it should just take a couple seconds to deploy. Okay, there we go. So now we've got a different bucket. This one's in EU West 1. Can open this up again. And we see we get the content we expect. So we get that hello Pulumi from production. Okay, great. So now we've stood up our second stack as well. So I see there's another question. Let me jump over to that and see if we can answer it. So it says, how did Pulumi stack know to connect to the right AWS account? Probably doesn't see the authentication step. Yeah, that's a great question. So by default, Pulumi uses the ambient AWS credentials you have set up. So if you haven't yet run this, you can run AWS configure with the AWS CLI, or you can set some AWS environment variables that both Pulumi and pretty much every tool that works with AWS will sort of use those because all the AWS SDKs understand how to work with those configuration settings. But you can check, what will get used in a sense by, AWS has AWS STS get caller identity, which tells you kind of who you are. And so right now I'm deploying with this user ID into this account and with this, kind of user. And so that's the user that's going to be used. I could set a bunch of configuration settings. So actually, let me just jump over and show you some of these. Cloud providers, there we go. Yeah, so in the AWS Cloud Provider, you see at the bottom here, there's all the different configuration settings you can provide. And so, for example, down here, there's profile. So this specifies which profile in my AWS configuration to use. Or if I want to directly pass my access key and secret key, I can do that as well. That's not necessarily recommended, but you can do it if you need to. You can also override the region to use, a whole bunch of different settings that are available that basically let you configure your credentials however you want to. And many of these, as this documentation describes, many of these can be set with environment variables as well, so you don't have to pass them directly. One other thing, while kind of talking about some of these things, another thing to really note is, highlighted sort of the Pulumi console as well. One key thing about the way that Pulumi works, when we do this Pulumi deployment, all of the conversation between the Pulumi CLI and your cloud provider is being done from your local machine here, or from your CI/CD environment, wherever it is that you're running Pulumi. So the only thing that's going up to the Pulumi service is actually the checkpoints of the state of the deployment, so that it knows what resources are under management. But the Pulumi backend doesn't actually ever see any of the credentials or have access to anything in terms of your AWS account. So all that is managed entirely within the CLI and in your local environment, and you can lock that down in whatever way you want. Okay, so let me just go one last step on this tutorial, and then since we have got a little bit of time, we'll probably dive into the next one. But if folks do have questions before we dive into the next one, get them ready, and we'll answer them in just a second. Cool. So for the last step of this, I'm going to just clean up the infrastructure I created. So I ended up with two different stacks with different resources in them. I want to kind of clean these up cleanly. So one of the nice things we can do with Pulumi is just cleanly destroy my resources. So many sort of manual provisioning tools and bash scripts and things make it very hard to actually clean up after themselves. Pulumi understands all the different resources under management, and so it can cleanly destroy them in the correct order. And so if I go ahead and say yes, this will delete these resources. And now that deleted the resources, but my stack is still there. So all the different configuration, all the history of the deployments I've done is still there. So if I want to also clean up all that history of the deployment itself, I can do Pulumi stack rm prod to delete this prod environment. Make sure that I really want to, and I'm going to go ahead and say yes. Okay, so now if I do Pulumi stack ls, I'll be down to one stack again. So now I can do Pulumi destroy on that stack. Now, one thing you'll notice is that this stack is not selected. So there's a star next to it if it's selected. This one's not selected. But what I can do is I can actually pass -s to pick a specific stack and run my operation against that. So I'll just do Pulumi destroy -s dev. Go ahead and say yes to destroy those 3 resources this time. And then again, Pulumi stack RM dev. Okay, so there we go. So now we've cleaned up after ourselves and all those resources are gone. Okay. So with that, let me just check in again on how folks are doing. So I'd love an update on kind of where folks are at on Lab 1. Did folks manage to get it all done or is anyone stuck along the way? All right, looks like we made some more progress there. Okay, so what I'm going to do, since we have a little bit of time and haven't had too many questions yet, we'll dive into the second part on the lab and kind of go through working with EC2 and with some more complex cloud resources as well. Okay, so if folks do want to follow along with this, this is going to be the lab 2 here. So we're going to be working with EC2 VMs and with a few other AWS resources. All right. So first, I'm just going to clear out all the code I've got here. I'm going to kind of start again with my code. So with this time, I'm going to start and I'm going to make it a little bit simpler to access this and import Pulumi AWS. I see there's one question. I'll just address that question while we have it here. So it says, any resources on best practices on organizing a Pulumi project for more extensive infrastructure with hundreds of resources? Yeah, so that's a great question. So I think there's two parts to that. One is, you can have a single Pulumi stack that manages hundreds of resources. We see that kind of thing all the time, especially with things like for loops and things. You can easily spin up a lot of different resources and manage them. But what we find is that oftentimes when folks have large amounts of cloud infrastructure, there's actually natural boundaries in that infrastructure where the infrastructure is either owned by different teams or versioned at different paces in a meaningful way. And in some sense, that's, maybe I've got my core VPCs and networking infrastructure, and that's going to change relatively infrequently. And so I don't want to have that be changed, being part of the same deployment lifecycle as my higher level things like my clusters or maybe even my application delivery. And so Pulumi makes it really easy to create multiple different projects, multiple different stacks that represent the different parts of your application. And in fact, those can even refer to each other. So there's a thing you can do called Pulumi. Oh, actually, let's do import Pulumi for now. I can actually do Pulumi. There's a thing called Pulumi.stack reference. And I can use stack reference to point at another stack in my application that I've deployed. So if I have maybe I have my project that defines my VPCs and core networking infrastructure. And I can actually, from a higher level stack, I can point at that stack. And so I can say, hey, I want to get the VPC stack. Now that I've got that, I can go and say get output. So I can go and get the output, the VPC ID maybe, from that other stack. And now I can use that in this stack. This allows me to sort of have a mix of things across the boundary and sort of still have a rich experience for working with those. So I can have some things defined in one project, but use those from another project. But I can still deploy those at different paces. But I'd say that when folks are getting started, we generally sort of think about having relatively few stacks to start with, and then learning about where the boundaries are between those stacks over time as the infrastructure gets more complex. And as it does, then we'll turn that into multiple different stacks and write the resource. Okay, great. I'll keep going here. So I got these resources. So now what I want to do is actually find an AMI that I want to deploy into my EC2 instance. And so what I'm going to do here is write some code that uses this aws.get AMI. And one of the interesting things about this is just a function that knows how to go off and look up the AMI that matches these criteria. So it's going to be the most recent. It's going to be owned by this, which happens to be the AWS account itself. And then it's going to match this name pattern. So it's going to be modern EBS-backed x64 volume. And so I can go ahead and do this. What I could even do is if I want to do, Pulumi.export Army ID, I can do this. I'm going to do Pulumi up. Now, actually, I forgot to create a stack again, so let me just create the dev stack. And it's going to tell me that I need to configure what region, because I deleted my region just a second ago, or deleted my stack just a second ago. So now let me do the Pulumi up here. And this won't actually deploy any resources, but it will run this function to go off and figure out what AMI that is. And so when I say yes, there we go. So we see that it ran that function and found the AMI that we want to use here. Okay, so we know that's correct. Let's create some more infrastructure. So I can go ahead and create a EC2 security group. And so this again, very simple, just describing the ingress rules that I want to be able to ping this, and I want to be able to get HTTP traffic. And then finally, I'll create one more resource, which is going to be an actual EC2 instance. So this is going to be EC2 instance. I'm actually going to make it a T3 micro to start a little bit faster. It's going to use that security group that we just specified up there. So it's going to use that group's name as the security group to attach to the instance. And it's going to use the AMI that we discovered above. It's going to use that ID. And then finally, it's going to set the user data to be a little script which runs an HTTP server that serves hello world. So just a very simple way to deploy some code into that instance. And of course, to be good citizens, we're going to tag that resource as well. So finally, we want to just change some exports on this thing. So we're going to export the IP address, which is going to be server.public IP. And we're also going to export the host name, which is going to be server.public DNS. Okay, so now I'm just going to go ahead and say Pulumi up again. And so go ahead and deploy these resources. So deploy the security group, it'll deploy the instance. It knows they depend on each other, so it'll deploy them in order. And it's telling me that it's going to output the host name and IP, but it doesn't know what their values are yet. So go ahead and say yes to deploy that. Okay, so it's going to take just a second to spin up that EC2 instance. There's another question I see from Srinivas. It's great if we can create automated way to create entire stack. Is there a way to lock the prod stack so it doesn't delete the entire prod with one click by mistake? So yes, so there's a couple of things related to that. One, there's the ability to have role-based access control, at least with the kind of Pulumi service backend, that constrains who has access to do operations on stacks. And so you can limit that capability to modify the stacks at all down to a certain set of users. The other thing we can do is on any resource, we can actually specify why it's not showing up there. So there's a resource option called protected that we can use to specify that any resource is protected and can't be deleted. And so to delete it, you'd actually have to remove that protected attribute from the resource manually. You do a deployment like that, and then you can delete it. So that makes it very hard to accidentally delete something, even if you do have the access and rights to do that yourself. So yeah, so there's a bunch of tools there to that. And in terms of automating the creation of an entire stack, absolutely you can do that. I mean, it's a combination of just Pulumi stack init and Pulumi up. Those are very easy to script together. So we have --JSON support on a bunch of the Pulumi CLI commands. So you can write little scripts that will do a Pulumi stack init, set some of the configuration, and then deploy that if you want to automate the process of standing up a development stack. One thing along those lines, I'll highlight just a couple of things just over here we're looking at. So one is actually, if I come into this console, one thing I can actually show off is just I obviously, have not just the stacks that I work on, like this one I've been working on in the workshop, but I'm part of an organization, so I'm part of the Pulumi organization, our internal Pulumi deployment. We obviously use Pulumi heavily here. And so I can see a lot of the other things that have been going on inside the Pulumi organization. And so I can see things that have been deployed into, this is www.pulumi.com's production deployment, right? So the website that you go to, this is a stack that manages that. See the Pulumi service itself, the production deployment of that happened 3 hours ago. So I can see sort of all those stacks being managed. But one thing I'll also show is, if I come over into, kind of Pulumi docs is one example of this. I go and look at a PR that someone's opened. This is an example where we actually have a little automation that we built, and it's a very easy kind of thing to build. That just automates when a PR gets opened. It actually creates a new Pulumi stack that is a representation of our docs website, and it deploys the state of that PR into that stack by default, and then creates a special copy of it here. So this is, if you use something like Netlify or something like that, this is kind of like that, but just something that we are able to create ourselves with Pulumi. So here we go. Here's another copy of the whole Pulumi website, but with the version of the code that's in those changes. And so that's an example of this automating that process of creating an entire stack. And then, of course, we actually also take care of when the PR gets closed, we tear down the stack so it's not using up resources. So great question there. All right, any more questions, or I'll keep going? Cool. Okay, I'll keep going here then. So our EC2 instance is now running here, and so we have its host name here. So we can go ahead and actually just hit that host name and see if it's serving the content we expect. All right, there we go. So we curl that endpoint, and we see it prints out hello world, which is what we expect right here. Cool. Okay, so we have a EC2 instance up running some custom code that we wanted to write. But like we did in the previous example, it's always more fun to have more instances. So why don't we go and sort of create a loop that creates one EC2 instance per availability zone. And so I can go ahead and create 2 arrays that are going to collect the IP addresses and the host names. And then I'm going to say for AZ in. I'm going to use another one of these get functions. And this one's going to be called get availability zones, which gets all the availability zones that are available to me. And I'm going to get their names. Now for each one of those, I'm going to create an instance. I'm going to tab that in. And I'm going to make a couple of changes to this. So the first is I'm going to set the availability zone here to be AZ. And the second one I'm going to do is I'm going to change the name to actually be, use a Python F string here to attach the availability zone name to the end of the name of my resource, so that each one of my instances has a different logical ID that I can refer to. Then finally, I want to change what I actually print out, the code I run on the EC2 instance. And so I'm going to use format to add the availability zone into here. And so all these are, again, these ideas where I'm just using a lot of little features from my programming language. I'm using for loops, I'm using these format strings, I'm using F strings here. I'm using just arrays and dicts from my language. And all the tools that I'm using, the sort of IDE tooling and the what have you. So using those to sort of make it a little bit easier to work with my infrastructure here. Okay, so now I can do ips.append server.public IP. I can do host names. Public DNS. Okay, and now instead of me exporting just one, I'm going to export all of them. Okay. Now I'm going to do Pulumi up. We should see a few things. So one, we're going to have to create an instance per availability zone. So we're going to see it's going to create actually 4. Oops. Mixing my TypeScript and my Python. So go ahead and do that again. We don't need a $sign in there. Okay, so now we're going to create these 4 instances, one in each of our availability zones, US West 2A, B, C, and D. And I'm going to delete my existing web server with this name. So I'll go ahead and say yes. All right, so this is going to take just a second to spin these up. So if there are any questions, happy to answer 1 or 2 right now. All right, so these instances are very quick to create. They actually take a little bit longer to delete, which is okay. So let's open up another console and we'll actually try out kind of hitting all of those. So what we're going to do is actually do a little bit of bash here. For each one of our ability zones, we have 4 of them. So we'll loop through and we'll curl and we'll look up the ith index of the host names. So there we go. As we go through each of the availability zones, we hit those instances, so we curl them, and we get back the strings we expect, A, B, C, D. So there we go. We can hit all of our different instances. And actually, one thing I should note, this JQ thing here, just using to parse some JSON. One of the nice things about the Pulumi stack output is that I can get it as JSON values. And so when I do Pulumi stack output, host names, that is just some valid JSON. And so I can pipe it into tools like JQ to interpret it and script against it in this way. So if I'm automating standing up my stacks, I can also automate getting information out of those stacks and putting that back into other tools like CI tools or what have you, or other deployment tools. Okay. Great. So we cleaned up that last resource. So now we've got the 4 instances running that we expected to here. So the next step of this, we got these instances and we can hit each one of them, but we kind of want to have one endpoint that we can hit to sort of connect to all of them. And so for that, of course, in AWS, we use a load balancer. And so let's add a load balancer to this code. So the first thing we're going to do, we're going to just to keep things simple. This isn't what we do in our real infrastructure, but just to avoid creating too much new stuff. Let's create a egress section in the same security group. And I'm going to allow egress through port 80 as well. Now I'm going to reuse the same security group for 2 purposes. I'm going to use it as a security group to apply to the EC2 instances. I'm also going to use it as a security group to apply to the load balancer, which of course needs to be able to have egress on port 80 so that it can reach out and connect to the EC2 instances. Okay, so with that, I'm going to add some code to actually create my load balancer. So first, I'm going to use a few more of these get functions. So I'm going to use get VPC. I'm going to ask for the default VPC. Then I'm going to get the subnet IDs associated with that default VPC's VPC ID. So these are just data I'm going to want to use to pass into other things. If I wanted, I could create my own VPC here and make sure that everything got deployed inside that VPC. I could do whatever I want. But here, we're just going to use the default VPC that we know already exists in our account. Now I'm going to create a load balancer. So it's going to be external. It's going to attach that security group that we just modified. It's going to use those subnets. So it's going to run the load balancer across all the different subnets in our VPC. And we're going to use an application load balancer. So the layer 7 load balancer that AWS supports. And then there's 2 more things for folks who have worked with AWS load balancers. They'll be familiar with these. So there's target groups. So these are the group of things that are going to serve requests through this load balancer. And so in our case, it's going to be our EC2 instances. So we're going to create a target group running on port 80. That's going to connect to targets running on port 80. It's going to serve the HTTP protocol, and it's going to use the IP target type. And then the last resource that we need is we need to tell the load balancer what to listen for. And so we're going to create a listener, which is attached to that load balancer. Listens on port 80 for user traffic, and its action is to forward to that target group we just specified. Okay, there we go. So now we've got that load balancer. All we need to do is actually add our instances to that load balancer as we create them. And so as well as these things, we're going to create a load balancer attachment. So a target group attachment attaches to that target group each one of these private IP addresses and targets port 80. Okay. Then the very final thing we want to do is just to export the load balancer's IP address. So we'll create the load balancer's DNS name. Okay, so now I'm going to do Pulumi up one more time. And we'll see again, we didn't have to modify our EC2 instances. They're all unchanged here. But we do need to update our security group, and then we do need to create all these other resources. So you'll actually see the dependencies between these resources are actually kind of interesting. And so I'll run this and we'll kind of see what happens. So you'll notice that the target group is able to create right away, and it's already created. And in fact, even the target group attachments that are attaching those VMs into the target group already are done. But the load balancer is still waiting to create. And then the listener hasn't even started yet because we have to wait for the load balancer to finish creating before we can create our listener. And so this is actually one of the things that Pulumi really, and infrastructure as code really takes care of for you, is dealing with all these complicated dependency relationships, making sure that when a resource does get updated, that all the right dependent other things get updated, and keeping track of all that bookkeeping for you, so you don't have to kind of do it manually in your bash scripts or in your own tooling. And so in this case, it's just creating a bunch of resources, but it's still doing that reliably in the correct order, such that this will deploy reliably every time you go and try and stand up a new stack. All right, so we'll give it just a second to create the load balancer. Load balancers always take just a little bit longer to stand up. All right, there we go. So now we've got our URL here, so we can go and curl that. So we can say 10 times we're going to curl that URL. Oops. There we go. Okay. Guess the listeners hadn't fully connected yet. So yeah, so there we go. We see as we hit that that load balancer endpoint, it's going to balance that traffic across the different AZs where we're running. I think if we did it enough, you'd probably start seeing a pretty reliable pattern of round robining. But ultimately, the AWS load balancer is going to decide how best to serve up this traffic. So there we go. So we created a load balancer, attached all our instances into it, and are seeing that kind of work correctly. Now, of course, this approach that we're doing here, kind of manually attaching our instances into a load balancer, in practice, we'd actually use Pulumi to stand up an auto-scaling group or something like that, set some desired state on the auto-scaling group around how we want it to scale up and down related to the traffic and manage things that way. And of course, we could do that here as well. This example just let us show a bunch of the interaction of the underlying pieces manually. And so I'll see a little bit more with kind of auto-scaling groups and some of the other compute primitives as part of looking at some of the higher level things around Kubernetes clusters and that sort of thing in the next section. All right. So that's the end of this second lab. And so let me switch back into the slides. Oops. So for the second half of this workshop that we'll do next Thursday, we'll actually go into a couple of additional topics. So one will be some more advanced infrastructure as code topics. So we'll touch on a couple of things: testing, how to integrate with CI/CD, some of the additional things that we might want to be curious about in terms of how we work with more complex scenarios with infrastructure as code. And the second one is we'll do some tutorials that go a little bit deeper on more advanced workloads, like working with a Kubernetes cluster and working with Kubernetes resources, and how we can use those as well within Pulumi. Just like we worked with the AWS resources, we can work with kind of Kubernetes resources or other resources we're working with. And so we'll look at both of those as part of next Thursday's workshop. So definitely encourage folks who are interested to sign up for that and join us for that one. If you do have more questions, we'll be around for a few more minutes to kind of answer those. And otherwise, there's a bunch of resources available here, either in our docs. You can reach out to me on Twitter or in email. And we have tons of examples. I'll just highlight that really quick. If you are looking for examples of a more specific kind of project you have in mind, you want to do something with SQS, or you want to do something with AppSync, or you want to work with a Slack bot, we have I think 120 or so examples here in this Pulumi examples folder. So you can jump in here, look for something that looks a bit like the kind of project that you're interested in working on, and maybe start with that example to sort of get off the ground. So definitely a good resource there. All right, and then as I mentioned at the beginning, we do have a Slack channel at slack.pulumi.com. You can join that Slack channel, and that will give you access to how you can ask a bunch of questions on an ongoing basis as you try out additional things with Pulumi. All right, so I see one last question, so we'll take that. Question is there a way to create a beanstalk pattern for AWS using Pulumi as well for less complex use? So yeah, so this may be sort of relative to the Kubernetes perspective in terms of the complexity. So in some sense, for really less complex use cases, you can almost build your own beanstalk, using Pulumi, right? So you can stitch together the different resources that Beanstalk manages on your behalf directly using Pulumi if you'd like. You can stand up your own auto scaling group. You can stand up your own CloudWatch logging, that kind of thing. If you do want to use Beanstalk, you can, of course, there are resources available for Beanstalk as well. So I could come in and say, Beanstalk. This is Elastic Beanstalk. Here we go. Yes, AWS.Elastic Beanstalk. And now I can create an AWS Elastic Beanstalk application and environment, all the kind of pieces that you typically work with Beanstalk. And so I can specify all of those using Pulumi as well, and then automate the creation of those Beanstalk-backed environments and changes to those environments using infrastructure as code as well. So if you do like a lot of the sort of operational benefits that you get from Beanstalk, but still want the sort of desired state infrastructure as code model, you can definitely do that using Pulumi. Of course, using Pulumi then also, and this is true both for Beanstalk and for Kubernetes and for kind of anything you would work with, you can then sort of mix and match the best of both worlds. So you can use Beanstalk for all the stuff that Beanstalk's great for, but when there's something Beanstalk doesn't support, like maybe there's a data store you want to use in AWS that Beanstalk doesn't have direct support for, so you can also spin up that resource and then connect that into your Beanstalk through an environment variable or what have you. So your application code has access to those resources as well, and still manage all of that in a single reliable deployment. All right. Great. Well, with that, I'll probably say thanks to everyone for coming and thanks for joining in for our workshop. And hope to see you again next Thursday to go through some more advanced infrastructure as code scenarios. If folks do have more questions, feel free to reach out. But otherwise, have a great evening.